Used tires are a real source of pollution. This pile represents about 100,000 of them. At any rate, these tires will have a second life. They'll be recycled to make rubber mats. Each day in this factory, they recycle 15,000 tires into mats. Tires have to be reduced to little granules, but first, this conveyor feeds the tires into the washer. Tires are washed with a water-based biodegradable preparation. Then they're sent to the shredder. The shredder has 2 rows of large teeth. These grind up the tires into pieces. This shredder is able to cut up almost 1,000 tires an hour. They come out as fairly good-sized pieces of tires, which are then shredded a second time. Metal is magnetically separated from the rubber, and the metal pieces are recycled at another factory. Other components of the tires, such as fiberglass and nylon, also have to be separated. They use a sifter to get out unwanted rubbish. Recuperated rubber particles purged of foreign materials measure about 2.5 millimeters. Some 16 tons of tire particles are piled up in this recycling depot. But the particles are still too large to be used. They're sent to a secondary shredder's supply tank, where they'll be reduced even further. This tractor feeds the secondary shredder. Grinding action produces a kind of rubber powder. The powder is spread out on these enormous molds. This mold has a length of 7 meters and a width of 1.2 meters. Thickness varies according to the product being made. The molds filled with rubber powder are stored in this loading magazine of the press. Once full, the molds are sent to the rubber mat press. Here's the mat press. The powder has to be cooked at a very high temperature for about 30 minutes. Cooking time depends on the product being made. The cooked mat goes through the unmolding unit before being sent off to cool. The rubber mats are still extremely hot. They're cooled with jets of water for a period of several minutes. The cooled mats can now be sent to the next department. This conveyor in the cutting center positions the mat before it's cut. The mat is vibrated to eliminate any surplus water. Each rubber mat is now cut up into 3 pieces. The cut mats are then stacked into a pile and stored before being shipped. The company also makes mud guards. These are fabricated the same way as the preceding mats. After having been cooled in water, but while they're still warm, they remove the surplus rubber. This operation is called notching. Hard rubber rings are also produced at this facility with the same fabrication methods and, as always, from old, used tires. Over a 12-hour period, this facility makes no less than 12,000 rubber mats from old recycled tires. This translates into good news for our environment.
There was a time when exposing your hardwood floors meant you just couldn't afford wall-to-wall carpeting. Not anymore. Hardwood floors are definitely in. And today there are so many wood and stain color choices, hardwood floors can suit any decor. The types of wood commonly used for flooring include red oak, beech, maple, white oak, walnut, birch, and ash. As soon as the wood arrives from the sawmill, workers at the floor factory stack it on racks, then pile the racks floor to ceiling in a dryer that's the size of a large barn. There, large fans circulate hot air around the racks. The wood's moisture content is between 40 and 60%, depending on the season. When that drops to about 7%, the wood is ready to come out. This drying process takes anywhere from 10 days to a month. The length of time varies because some species dry out much slower than others. The wood is in random lengths and widths, so the first step after drying is to cut it to standard sizes. On the way to the ripsaw, the planks pass under an optical device called an optimizer. In mere seconds, it reads the dimensions of each plank and sends that information to a computer. The computer calculates the greatest number of standard-sized pieces that can be cut from the plank, then guides the ripsaw to cut accordingly. This maximizes the yield and limits waste. Flooring is made from medium quality rather than top quality lumber to keep prices competitive. As the pieces exit the saw, workers manually cut out any large knots or other defects, weak points at which a piece could potentially snap and jam up the equipment. The pieces now travel to a machine called the molder. Its revolving steel knives spin at a rate of 6,000 rotations per minute, carving a tongue down one side of each piece and a groove down the other. Workers do frequent spot checks to make sure the tongues and grooves fit together snugly. The next machine carves grooves on what will be the underside of the pieces. This is for air circulation and stability. Then, an embossed wheel imprints the words, "Made in Canada." Using cross-cut saws, workers remove any faults in the wood and divide pieces that have noticeable color variations. This is the first step towards sorting the wood by grade. Now a machine called an end matcher carves a tongue and groove on the two ends. Here's the view from inside the machine. Workers check once again for faults. Then, assessing quality and color, sort each piece by grade. This will be pre-finished flooring, so the pieces now run through a sander to prepare them to receive 8 coats of varnish. For certain finishes, the first coat contains wood stain. All subsequent coats are colorless. Between each application, ultraviolet lamps dry the varnish in just a few seconds. As the flooring exits the last drying oven, it's ready for packaging. Unfinished hardwood flooring has to be sanded, stained, and varnished after it's installed. Pre-finished flooring eliminates that extra work, sparing you the dust, the drying time, and the smell.
Lapel pins let you proudly show off where you've been or where you stand. From an event you've attended or your political beliefs to your professional affiliation or your favorite sports team. Lapel pins cost pennies to produce, but some are collector's items worth thousands of dollars. They may be tiny, but they're out there in huge numbers. This one company churns out about 5 million lapel pins a year. It all starts with a sketch of the pin design, and from that, the master, a negative made of magnesium, a type of metal. They'll make copies of this master to create a production mold. But first, using what's called a coping saw, they cut out the front and back pieces of the master. Using a dispenser about the size of a sewing needle, they glue the pieces together with epoxy. It takes 5 minutes to dry. Then they cast enough copies of the master to fill up a rubber disc. After tracing the outlines, a worker uses a surgical knife to meticulously carve out the cavities. He softens the rubber with paint thinner to enable precision cuts. Then he places a copy of the master in each cavity. Another disc goes on top. Then it's into a machine called a vulcanizer for 1 hour. This machine uses heat and pressure to cure the rubber, making it as hard as a car tire. It also melds the rubber around each master copy, embedding the detail. This will be the production mold for producing this pin design. Now, using a surgical knife again for precision, they carve out sprues, channels that during the casting process will direct the flow of molten metal to the cavities. They also make smaller, curved channels called runners to filter out any air or dirt particles. It's crucial to position the sprues and runners correctly because this mold produces an entire line of a particular pin. Mess up and they'd have to remake the mold from scratch. Next, they insert a centimeter-long brass tack called a post into each cavity. It'll later fasten to a clasp, attaching the pin to clothing. The post goes in now rather than later so that it will fuse to the back of the lapel pin during casting. Now to close the mold, they align the buttons on one half with the depressions in the other half. The mold then goes into what's called a spin casting machine. Using a cast iron ladle that can withstand the fiery temperature, they pour in molten metal, either pewter, zinc, or a tin alloy. As the machine spins, centrifugal force propels the metal into every nook and cranny of the cavities. After a minute of spinning, 400 rotations, the mold comes out. The metal takes about 5 minutes to cool and harden. The factory remelts the excess metal for the next batch. Next, a brass clasp called a clutch goes onto the post. Now the lapel pins go for an hour-long wash in soap and water and abrasive stones. The stones smooth out any rough edges. The pins go into the electroplating tank for a surface coating of metal. How many coats and the types of metal vary with the design. An electric current draws the metal particles onto the pins, plating them thoroughly. These pins first get copper plating, then nickel plating, then gold plating. Now it's time to paint the lapel pins. Workers follow a numerical guide like a paint-by-numbers kit. They paint each pin individually using minute quantities of epoxy paint. They control the paint syringe with a foot pedal. Once the paint dries, a machine called a pad printer gathers up ink and stamps on the tiny details, the ones too small to paint by hand. Pierce the post through the fabric, secure it with the clutch, and this lapel pin is now ready to wear.
If you think a baseball bat is a pretty simple thing, well, you're out in left field. Making a bat means balancing things like weight and thickness. The material it's made of can make a difference. Metal bats hit the ball faster. However, the pros use wood bats because of league regulations, and even the type of wood might impact the score. Barry Bonds cracked a home run record in 2001 with a wood bat like this, one made of maple, instead of the usual white ash. They can never tell just by looking at it that a chunk of maple has what it takes to make a good bat. So they weigh it to make sure the wood is really as thick and heavy as it appears. Next, pointed prongs grip the wood and spin it, while a carbide cutter rounds it. This is a very modern lathe called an XY machine. The rounded blank goes into a room called the library, joining others on the shelf that are waiting for their chance at the big leagues. A worker selects one of the blanks to fill an order that specifies a certain model and size. He weighs it again to make sure it measures up to what the player has ordered. The blank goes onto the XY machine and spins. A computer guides the cutter as it moves on rails and carves into the blank. It whittles 2.5 centimeters of wood from the blank in order to form a handle. It takes a total of 3 passes on this cutter to make the rough shape of a baseball bat, but it's quick work, completed in just 3 minutes. Now it's time for another weighing in. The bat is substantially lighter, which is what they want. Next, he measures the end of a completed bat with a caliper. Using a square-edged scraper, he rounds the knob as the bat spins on a more traditional lathe. He measures as he cuts. With another caliper, he checks the thickness of a completed bat and compares it to the one he's just carved. Now he takes a turning tool called a skew chisel. With its pointed tip, he cuts into the bat's handle just above the knob to narrow the shoulder. Again, he measures as he cuts to make sure the diameter is just right. Using the skew chisel, he shapes the slope of the bat, repeatedly checking with the caliper to make sure it meets specifications. He slims down the handle a little more. Then he angles the top of the knob with the chisel. He shapes the rest of it with a square-end chisel. Next, he curves the bat's barrel using the same tool. This gets rid of sharp edges that would cause a ball's impact to ripple down and jar the player. Then he goes back to the knob and completes the shaping with the skew-end chisel. Because the tool is extremely sharp, he can carve very precisely. The bat is now within 14 grams of its final weight. Using an electric sander, he smooths down some of the rough edges. He switches to a finer grit to finish off the job. As he sands, he measures, because this isn't just about getting the surface smooth. The bat has to be exactly the right size and weight for the player it's being made for. Now he places the bat's knob in an end mill. A spinning carbide disc cuts around the holes made by the pointed grippers on the lathes, producing a gentle scoop. Next, a bigger disc carves into the barrel, cupping it. Some players prefer a cupped bat because it balances differently. Now he places the bat on the scale for the final weighing, and it's exactly what the player ordered. He brushes paint onto the barrel and rubs stain into the lower half of the bat. He presses decals onto the bat so it sports both the brand name and distributor. Then he stamps the model number in gold ink and tops everything off with a light coat of varnish. Now this maple bat is ready for the big leagues and some heavy hitting.